Okay? Perhaps? No. Well, seems to be working for Twitch, but not for YouTube. That's alright, though. Well, let's... Ah, there we go, there we go. Alright. Pop up. Listen. Let's check sound on the other places. Works fine. Good stuff. Alright, that should have been a lot easier. I am incredibly tired right now, so, well, that's no different than usual. But hey, let's continue forward. We stopped 2 weeks ago. I messed up. I set an alarm for a half hour before this thing, woke up at 11:30 p.m. The alarm was, well, for the AM. Terrible time. Last time we were looking at macros, however, which I don't fully remember the syntax for. Right, what's going on here? We got ident, which is brought in from X. I'm just gonna jump in, by the way, fuck it. Yeah, so we got ident, which is brought in... Sorry, which X is mapping? No. Ah, yeah, patterns. This is a pattern. Right, so anything right, so this is matching I as an identifier, a comma, and anything after that as a repetition of this pattern. So this will match X and Y as like as a list of items equals the expression. Okay, so Y is the expression. So no, S is the expression, my lord. Apologies. That is brought in as anything after an equal sign. What is this even doing? Yeah. So this is kind of like a for loop by my understanding. So it'll run this as many times as there are parameters within this mini-let macro loop. Good stuff. It'll output let mutable taking in from I, the identifier, which will at first be X, equal E, which is the expression of S, S being let mutable string from A, so that'll be A. Okay, so that's just going to be replaced with let mutable X equal S, and separately on a new line, let mutable Y equal S. Good stuff. Then we X.push string. It's immutable, so that's fine. B. Right, yep, so X will now be AB. I wish I remembered a song from ABBA. I do not remember that. I remember their name, though. I'm gonna listen to some ABBA later tonight. I don't know if it's called ABBA, but I'm putting it in a list now. It's coming on. Right, so that will be the thing. It'll be ABA. ABBA. Maybe that isn't a band. Is it a band? Nah, it's ABBA, I think. Yeah. I was wrong on that. I feel shame. But I believe that will compile, and that's fine to compile as ABBA, as we have. Yeah, I don't see any issue directly. Yeah. Oh, well, maybe not. Strings don't implement the copy trait. So this is going to be a reference, right? And we can't have multiple references Shoot, I forgot about that. Ooh, maybe it won't pass the compiler. Right, now that I think about it, yeah, because this is going to be... It is both S, and strings don't implement the clone nor copy type. Is equal to S, so we can't just clone it over. I don't think so. And thus, I don't think this will compile. Now that I think about it again. Yeah, I think that is an issue. Right, I don't think this is going to compile, and to state my reason quite clearly, it's due to the fact that a string does not implement the copy nor clone trait, and thus cannot be set to the, and thus must be a reference, thus it cannot be placed into two places and then utilized like this. That can't happen. That's not allowed. Alright. Which of the following are valid reasons for implementing a macro as a procedural macro instead of a declarative macro? I'll admit I've forgotten what these two things are. Right. And then, right. So, procedural macro, I'm assuming, is like the previous type that we had just seen, versus a declarative macro, which I can't remember. Your macro requires an entire item as input, not just an expression. Implementing a macro as procedural macro instead of a declarative macro. You want to generate variable length sequences of code. Assuming that's what I'm talking about, then yes, that is a valid reason. You want to integrate with Rust's drive system. I seem to remember that being an issue, but I don't remember it explicitly and thus will not answer it as such, as I do not know. Your macro requires non-trivial analysis of the macro's user's syntax. Because it's pattern matching, right? I believe that to be a correct one. Let's go with that. Which of the following best describes the input to a procedural macro? The input is an abstract syntax tree. Yeah, that's it. That was really cool. The input is a typed control flow graph. Nope. The input is a sequence of tokens. Maybe it is. No, you build out an abstract syntax tree. I mean, that is... An abstract... No, it's not really a sequence of tokens. That's lexicographical stuff. An abstract syntax tree is built up of these sequences. I believe that's what it is. If it says sequence of tokens, then I'm misremembering. Oh, shoot, it is a sequence of tokens? No. It is! What's up with the abstract? What's AST? What is the AST? Right, this is within. Right, a token stream. The input of it is a token stream. Oh, yeah, it's a token stream that we then have to use, like a parser to create an abstract syntax tree from the token stream. I forgot, yeah. That's good to remember. So, the progressive macro takes in a stream of tokens, which is just whatever code is put into the macro, and then you can, if you so wish, construct a representation as an AST. Okay, fair enough. Alright, and I got this one incorrect. I did get this one right, yep. Is it for the same reason? The menulet macro syntactically duplicates the expression E as a binding to each variable on the left-hand side of the equals. However, because S is an owned string, then the first binding to X moves S, and the second binding to Y is invalid. Yep. Procedural macros Here we go. What did I get wrong? Variable length sequences of code. You can do that with either. Now that I remember, you can do that with either. Apologies, I forgot. Your macro requires non-trivial analysis of the I believe that's correct, yep. Because it... Right, so previously you were doing it as a pattern. You're matching against a pattern within this. This is not the syntax that is being described with a progressive macro. This is a declarative macro. Because you were declaring... Well, I don't actually know why it's named that, but in order to remember that, it is declaring a pattern which is matched against. Whereas you're just directly from the lexer getting a token stream put into your can you just get an AST? Oh no, that's the implementation of it. Okay. Yeah. Yeah, okay. Since you're just legitimately getting a full-on token stream, you can do essentially anything you want with it. You can write whatever code from it you wish. Okay. So this is kind of like injected into... I wonder, is this injected into like the process of compilation? Where does all of this happen? Does like it lex the entire thing, it hit this hello macro derive, and then just stop at that point, allow it to build out its code, and then lex again? Or are all the macros built out previously, the lexer being brought in order to take out the tokenizer, and then like because you are just directly taking, just parsing the token stream into the my god, into the ASD, abstract syntax tree. So the best place for this, I would argue, would be after lexing, before parsing. But you could, of course, do this all before the lexing even happens for the grader or not. No, that makes sense. Doing it before the lexing even happens so you have the actual code. I'm sorry. Incredibly tired. I'm not thinking things through. Okay. Good to know, I believe. Right. The input to the procedural macro is a sequence of tokens. Yep. Procedural macros take as input and produce as output token streams. Okay. You can use crates like sign to convert... Oh, that's a crate. Well, a crate, it's inside of the original project, right? Where do we import sign? Sign. Sign. Where are we importing sign? I can't even remember how to import. Yep, it's via use. Use sign. That's from something, isn't it? Token stream, quote, use, yep. Where does sign come in? It doesn't, is the answer. Alright. I'm just gonna assume it is. But it's not like just some random crate. It's probably within the actual thing. You don't gotta like install it or anything, right? Probably right there. Why would you have to install it? If you have the Rust compiler, you should have something that'll build out an abstract syntax tree for it. Why can't you just use that bit? Unless that's all... Well, that would all be compiled into the compiler, of course. It would likely be the same code. Yeah, okay, never mind. That does make sense. Why include that normally? This is not a normal thing to be doing. This is a niche within a niche. Well, on that, I'm going to continue. Summary. Woo! Now you have some Rust features in your toolbox that you likely won't use often, but you'll know they're available in very particular circumstances. We've introduced several complex topics so that when you encounter them, an error message suggestions or in other people's code, you'll be able to recognize these concepts and syntaxes. Use this chapter as a reference to guide you to solutions. Next, we'll put everything we've discussed through the book into practice and do one more project. Hell yeah. Final project, building a multi-threaded web server. That's wild. It's been a long journey, but we've reached the end of this book. In this chapter, we'll build one more project together to demonstrate some of the concepts we covered in the final chapters, as well as recap some earlier lessons. No quizzes, this is a walkthrough. For our final project, we'll make a web server that says hello and looks like figure 220-1 in a web browser. Hello, hi, from Rust. Here's our plan for building the web server. Learn a bit about TCP and HTTP. Listen for TCP connections on a socket. Parse a small number of HTTP requests. Create a proper HTTP response. And finally, improve the throughput of our server with a thread pool. Okay, before we get started, we should mention one detail. The method we'll use won't be the best way to build a web server with Rust. Community members have published a number of production-ready crates available on crate.io that provide more complete web server and thread pool implementations than we'll build. However, our intention in this chapter is to help you learn, not to take the easy route. Because Rust is a systems programming language, we can choose the level of abstraction we want to work with and can go to a lower level than is possible or practical in other languages. We'll therefore write the basic HTTP server and thread pool manually, so you can learn the general ideas and techniques behind the crates you might use in the future. Right? So this is an amazing beginning piece, really. Like, that's kind of impressive to have built. You got all the way through here and you build your own web server. This ain't like a... I was gonna make some... I am tired. I am incredibly tired. This isn't like some to-do app. This isn't like some simple application that you build out. This isn't like a text adventure, etc. This is something that, like, a person could be impressed that you made. You show this to your mom and she won't understand a thing. That's the sign of a good project. Right. We'll start by getting a single-threaded web server working. Before we begin, let's look at a quick overview of the protocols involved in building web servers. The details of these protocols are beyond the scope of this book, but a brief overview will give you the information you need. The two main protocols involved in a web server are Hypertext Transfer Protocol, HTTP, and Transmission Control Protocol, TCP. Both protocols are request-response protocols, meaning a client initiates requests from a server, which listens to the request and provides a response to that client. The contents of those requests and responses are defined by the protocols. TCP is a lower-level protocol that describes the details of how information gets from one server to another, but doesn't specify what that information is. HTTP builds on top of TCP by implementing the contents of the requests and responses. It's technically possible to use HTTP with other protocols, but in the vast majority of cases, HTTP uses TCP. We'll work with raw bytes of TCP and HTTP requests and responses. What does this mean? It's gonna be like the 64-bit. Oh, Lord. In my networking class, they used Lego for this. I wish I could remember it. I remember her talking about how the vast majority of people who I teach with Lego remember it because of the Lego. But all I can remember is the Lego. Because it was Mega Bloks. It wasn't Lego, it was Mega Bloks. She lied to us. But I don't remember the TCP request. I don't remember what's part of TCP, but yeah, I do remember. Yeah, okay, yeah. I do have an idea of what the raw bytes of TCP and HTTP requests and responses means. I will admit, as a web developer, I've never directly looked into what's inside of an HTTP request. That'll be news to me. Listening to the TCP connection. Our web server needs to listen to a TCP connection, so that's the first part we'll work on. The standard library offers a standard net module that lets us do this. Let's make a new project in the usual fashion. Cargo, new, hello. Let's get into hello. Right, and let's take this in. Right. We are in main.rs, good stuff. Now enter the code in listing 21 in source main.rs to start. This code will listen at the local address 127.0.0.1.78.78 for incoming TCP streams. When it gets an incoming stream, it will print connection established. Alright? Why did I do that? So we are using standard net TCP. This. Why is that? Huh. Does that exist? Expect you got a semicolon. Oh. Yeah. Yeah, it's not used, but that's correct. Right. So we are going to create a listener, which is going to be built from TCP listener bind. What does bind do? Create a new TCP listener, which will be bound to the specified address. Right. Pretty self-explanatory. It takes in a string holding the IP address with port. And this is going to be an option, which if it doesn't work, we just panic. Right. For stream. Okay, so it's some form of list object. Oh, no. Listener is a, quote, listener object, or, well, not really an object, item. Probably some form of struct, I would assume. What is it? Oh, yeah, it's a TCP listener. Yeah, it's just a struct. For stream and listener incoming, let stream equals stream dot onRep. Okay, again, it's an object. Right. Oh, I can't really remember. Is incoming going to give us, I can't remember, an iterator or? Huh. Yeah, it's just a result on rep. So it's an iterator filled with results? So there can be a failed result within a selection of these things, I guess. Sure. Print. Is it really going to be that easy? Yep. Seems to be. Well, I mean, writing TCP listener would probably be an entire thing. But you know, we just have it available to us. Good to see. Really easy to create a very small web server. I want to make my own TCP listener, whatever. Little TCP thing. I want to know how TCP works at a fundamental level. That would be a fun little project. Using TCP listener, we can listen for TCP connections at the address 127.0.0.1.7878. In the address, the section before the colon is, yep, that's the IP address, whereas this is the port. So this is just the, well, that's a U. 127.0.0.1 is U. Well, anything on 127 is U. That's the loopback address. Right, let's just read this. Other people may want to hear this, I guess, if anyone's actually watching. The section before the colon is an IP address representing your computer. This is the same on every computer and doesn't represent the author's computer specifically. And 7878 is the port. You've chosen this port for two reasons. HTTP isn't normally accepted on this port, so our server is unlikely to conflict with any other web servers you might have running on your machine. And 7878 is Rust, typed on a telephone. Oh, that's kind of cute. I like that. That's really cute. Right, so what it's saying here is that you may just have a different web server. Usually 8080 or 8888 is used for a web server that you're just running for anything, really. Node servers, I believe, default to 8080. I believe that Bundle, what am I talking about? Veet tends to do... Actually, no, I don't think it does 8080. I can't remember and have stopped caring. That's a really cool thing. Rust on the telephone. That's nice. The bind function in this scenario works like the new function in that it will return a new TCP listener instance. The function is called bind because in networking, connecting to a port to listen to is known as binding a port. Oh, hey, Sorbet! Yeah, it's been an amazing amount of time. Damn. Yeah, I missed last session horrifically, didn't I? I tried to get there, man. I set an alarm for 7, but it was 7 a.m., not 7 p.m., so I slept until 11:30. Little nap turned into a long nap. It is great to see you, though. We're building our own web server. Haven't actually gotten through too much. I am very glad to see you. Seriously, though, how have you been? I can't remember the last time. It's been like 5 sessions, probably a month and a half. Hopefully you're doing well. Sad to see you can't join every week anymore, but this ain't going to be happening for too many more weeks, is it? This may even be the last session. We got 3 different little things. That's it. Probably one more, but you know. Hey. You started software engineering. That is awesome. That is really cool. You're going to be way ahead of everybody else, I assume. That is really good to see. Hopefully you enjoy it. If you don't, keep going. Eventually you might. God damn. Seriously though, I'm incredibly happy. No, wait, computer engineering? I will admit, I don't know the difference. I was not a college kid like that. I went to community college. So you know. I feel shame for that. I feel sorry. But anyway, I hope you don't mind. I am going to continue with this. Congratulations on that for computer engineering. That is an amazing thing. Alright, using TCP listener, we can listen for... You don't know how... Oh no, I'm Canadian too. Wait, computer engineering? You're Canadian, computer engineering. That is an interesting thing, because Canadians aren't actually allowed to call ourselves engineers. Unless you're very specifically classified as that. If you get in the industry, you're going to be one of the few people actually allowed to call yourself an engineer legally. That's amazing. That's really cool. Usually it's called computer sciences. I've never heard somebody call it specifically computer engineering. Right. And the address. Oh, yeah, we've read that already. Right, I am going to continue though. Glad to see you. The bind function of the scenario, new function, TCP listener. It's called bind because, yep. The bind function returns a result, which indicates that it's possible for the binding to fail. Of course. If somebody else is utilizing it, it can't use that. For example, connecting to the port 80 requires administrative privileges. Yeah, that's usually HTTP. Oh. That's what we're writing, isn't it? No non-administrators can listen only on ports higher than 1023. I didn't know that. So if we tried to connect to port 80 without being an admin, binding wouldn't work. Binding also wouldn't work, for example, if we ran 2 instances of our program, and so had 2 programs listening on the same port. Because we're running a basic server, just for learning purposes, we won't worry about handling these kinds of errors. Instead, we'll use unwrap to stop the program if errors happen. Every time I just randomize a port with usually 5 numbers. So that's why I've never ran into this. So yeah, you know. Maybe it was 4, I can't remember to be honest. Hey. Right, the incoming method on TCP listener returns an iterator that gives us a sequence of streams. More specifically, streams of type TCP stream. A single stream represents an open connection between the client and the server. A connection is a name for the full request and response process in which a client connects to the server. The server generates a response, and the server closes the connection. As such, we will read from the TCP stream to see what the client sent, and then write our response to the stream to send data back to the client. Overall, this for loop will process each connection in turn and produce a series of streams for us to handle. Okay. For now, our handling of the stream consists of calling unwrap to terminate our program if the stream has any errors. If there's any errors, the program prints a message. We'll add more function. Sorry, if there aren't any errors, it just says, hey, connection established. We'll add more functionality for the success case in the next listing. The reason we might receive errors in the incoming method when a client connects to the server is that we're not actually iterating over connections. Instead, we're iterating over connection attempts. Okay. The connection might not be successful for a number of reasons, many of them operating system specific. For example, many operating systems have a limit to the number of simultaneous open connections they can support. A new connection attempt beyond that number will produce an error until some of the open connections are closed. Let's try running this code. Is this actually going to be as simple as this? Something's happened? Yeah, that's fine. Right, we are running. And let's go here. I hope I don't have anything on this board. Hey, good stuff. 4 different connections, 5. Is this continually trying? Because it hasn't gotten any response, has it? 1, 2, 3, 4, 5. It's tried 5 times. And that's it? Okay. Yeah, it even shows it here. The browser should show an error message like connection reset, because the server isn't currently sending anything back. When you look at your terminal, you should see several messages that were printed when the browser connected to the server. I'm curious what data exactly is being sent to the server for just a simple individual connection. No, I'm not. I know exactly what's being sent. I'm sorry about that. Sometimes you'll see multiple messages printed for one browser request. The reason might be that the browser is making a request for the page, as well as a request for other resources, like favicon, that appears in the browser's tab. Okay. So the thing here isn't it trying. 1, 2, 3, 4, 5 times, creating 5 different connections. It is currently attempting to get 5 different things on the server. The last 2 were probably attempts to reestablish a connection. But yeah, okay. I don't know what other resources other than a favicon the initial data would be. It could also be that the browser is trying to connect to the server multiple times because the server isn't responding with any data. I am curious to see how many of these just disappear after we actually give it some data. When streams goes out of scope and is dropped at the end of the loop, connection is closed as part of the drop implementation. Browsers sometimes deal with closed connections by retrying, because the problem might be temporary. The important factor is that we've successfully gotten a handle to TCP connections. This is incredibly cool. I'm just gonna say this again, this project is really cool as an end project to this book. Remember to stop the program by pressing Ctrl-C when you're done running a particular version of the code. You're not my mom, I'm just gonna leave it open. Then restart the program by invoking the CR command after you've made each set of code changes to make sure you're running the newest code. I wonder if there's a Rust version of, like, the myriad of different web server shit that allows you to just automatically recreate the server every time something's changed in the code. I assume so. But no. Rust takes a long time to compile. That would be quite annoying, I'd assume. Reading the request. Let's implement the functionality to read the request from the browser. To separate the concerns of first getting a connection and then taking some action with a connection, we'll start a new function for processing connections. In this new handle connections function, we'll read out data from the TCP stream and print it, so we can see the data being sent from the browser. Right, so we're going to create a new function called handle connection. We are going to, inside of this, right, so we actually need to bring in a few more things. IO and net. Right. I forgot about that syntax. I kind of hate it. Right, from net here, and we also need IO. We need prelude. The entirety, I can't honestly remember what that means. So everything with prelude? Oh, so everything within prelude. Yeah. And we need from net TCP listener and separately TCP stream. Right. When you need semicolon unmatched. Yeah. Oh, I see. Chill. Most are not used, but you know, that's alright. Alright, so we're going to take a mutable string of type TCP stream. We're going to create a buff reader, which is equal to buff reader new, passing in a reference to the string. We are also, wow, what am I doing? Going to create HTTP request. Which is a vector. Which is equal to a new buff reader. No. Buff reader Ooh, this is gonna be long. Lines. What is this doing? Beth reader. Who doesn't love a Beth reader? Is that working now? Is this correct? Now, what is this? New buff reader? Buff reader is unused. I have misspelled buff reader somehow. Oops. Forgot about that. Yep. Where's we go? Is that correct? Okay, I misspelled it. Great. Awesome. Yeah, we're not done yet. Right, so that is correct, but I still can't see what lines is supposed to be doing. This is also not working. What is the issue here? By the way, I'm trying to use a hover on this just to see what exactly any of this is. Is hover working on anything, though? Just gonna double check. Yeah, it is. It's working fine on a bunch of stuff, but not here. I wonder why exactly that is. It's not working on TCP stream either, so I'm just gonna have to assume that it's not going to. Alright, let's just continue forward, assuming that this will all work out perfectly fine with zero issue. Map. You're going to take result, and we're simply going to unwrap the result. Good stuff. You're going to then take while. I'll admit, I don't remember what take while does. Alright. So we're going to do something until it's empty. Is empty. There is some issue with my code somewhere. I can't see it, however. Dot collect. That's unused. Variable does not need to be mutable, so on and so forth. I'm simply going to print line. Request. HTTP. Request. I really don't think this is going to work. I think that there's some major difficulty or issue with my code somewhere. Rust Analyzer sees nothing. Oh. Dang. Right. Let's see it now. Works fine. Connection established. And we haven't actually run the code. That would help, wouldn't it? Handle. There's something wrong. It's not seeing anything. Is it because of this? No. Can't be because of that. Right, now we are actually running the thing. Stream isn't used at all? What do you mean? Mutable stream HTTP. That's in handle connection. Handle connection stream is not used. Yes, it is. It's used right here. Oh, because it's immutable. Sorry. Yeah. Right. Let's see if this is working now. Yes, it is. And here's a normal HTTP request. We got connection established. We got request is of type GET HTTP 1.1 connection. Yep. Keep live, cache control. This is all the default stuff. Hey, I'm on Linux. Oh god, what horrific information. Muslim? Yep. I don't know why that confused me. Yeah, it's going to be so. Roll 128. I'm really curious. I've never actually looked at. Is it going to tell you my actual IP address through this? Of course not. Why would it? It didn't actually route towards that, but. Ah, yeah, there we go. It does it twice. 3 times. So it does it 4 times. It did it 4 times. With the same information? Looks like it. Right. It didn't do it 5 times this time, it only did it 4, but we still haven't sent anything back. It's pretty simple, it's just giving us a bunch of information that the server might need. Hey, what type of request is it? We are currently trying to get something. The host, hey, here is where it is coming from. Connection type, I can't remember what exactly that is. Cache control, same with that. Just telling you how long to keep cache of it. I don't know what yeah. Platform is Linux. I'm on Linux. Here's the user agent, which is just a bunch of information that can be used to figure out exactly who you are, but it is useful for us to figure out exactly what you're doing or what device you have, thus the capabilities you're having. That's what we can do. And it accepts a bunch of different stuff. This is just what output it can receive. So on and so forth, just a bit of information that we will require. Oh, accept languages. Hey, we only accept English. I've never seen anything that tries to change that based on that. Usually it just goes to a specific area, or it takes a request from the location you're at, not actually from the accept languages. I've never seen that actually happen. Sorry, I'm rambling. I'm tired, and I will continue to do so. Right, so we bring standard I/O prelude and buffer reader into scope to get access to traits and types that let us read and write from the stream to the stream. In the for loop in the main function, instead of printing a message that says we made a connection, we now call the new handle connection function and pass the stream to it. I still say connection established. In the handle connection function, we create a new buffer reader instance that wraps a reference to the stream. Buffer adds buffering to manage calls to the standard IO read trait method for us. We create a variable named HTTP request to collect the lines of the request the browser sends to our server. We indicate that we want to collect these lines in a vector by adding the vector annotation. BuffReader implements the standard IO buffRead trait, which provides the lines method. The lines method returns an iterator of result, string, or error. By splitting, or error of type standard IO error. By splitting the stream of data whenever it sees a new line byte. To get each string, we map and unwrap each result. The result might be an error if the data isn't valid UTF-8, or if there was a problem reading from the string. Again, a production program should handle these errors more gracefully, but we're just panicking. The browser signals the end of an HTTP request by sending 2 new line characters in a row. So to get one request from the stream, we take lines until until we get a line that is the empty string. Once we've collected the lines into a vector, we'll print them out using pretty debug formatting so you can take a look at the instructions sent to our browser. Let's try this code, run it, and see what gets output. Oh, this has more information than I had. Accept encoding, did we get that? Yeah, we did. It's just in a different location. Depending on your browser, you might get slightly different output. Now that we're printing the request data, you can see why we get multiple connections from one browsers. I wonder what they're using. Are they using Linux or are they using Windows? Do you have information? No, they're using a MacBook, of course. Old MacBook, too. Dang. Good for them. Depending on your browser, you might get slightly different output. Now that we're printing the request data, we can see why we get multiple connections from one browser. Request by looking at the path after get. Oh, yeah, I forgot about that. We are getting slash, we are getting slash, we are getting slash, we are getting slash. We are actually not checking for anything else. We're just trying to get the root. We're trying to get the basic application. We're not trying to get anything else. We know the browser is trying to fetch slash repeatedly because it's not getting a response from our program. Okay, so it's not actually looking for the favicon. Let's break down this request data to understand what the browser is asking of our program. Closer look at the request. Right, HTTP is a text-based protocol, and request takes this format. Method, get request URI, slash HTTP version, we got 1.1 here, and CRLF, not certain. We have headers and message body. The first line of the request line the first line is the request line that holds information about what the client is requesting. First part of the request line indicates the method being used, such as get, post, so on and so forth. We got delete, replace, etc., which describe how the client is making the request. Our client used a get request, which means it is asking for information. It's asking for the server to send information to the client, not trying to give information to the server via a post request or asking for an action via any other request. The next part of the request line is slash, which indicates the uniform resource identifier, URI, the client is requesting. A URI is almost, but not quite, the same as a URL, uniform resource locator. The difference between URIs and URLs isn't important for our purposes in this chapter, but the HTTP request spec uses the term URI. Yep, so we can just mentally substitute URL for URI here. Okay? The last part is the HTTP version the client uses, and then the request line ends in CRLF sequence. Stands for carriage return and line feed. Oh, okay, yeah, that's just /r/n, which are returns from the typewriter dates. Yep. The CRLF sequence can also be written as /r or /return and /new line, where /r is the carriage return and n is a line feed. The CRLF sequence separates the request line from the rest of the request data. Note that when the CRLF is printed, we see a new line start rather than /r/n. Yep. These are escaped codes. Looking at the request line data we received from running our program so far, we see that get is the method, slash is the URI, and HTTP version 1.1 is the version. After the request line, the remaining lines start with hosts. Onward, sorry. Starting from host onward are headers. GET requests have no body. Correct? Try making a request from a different browser or asking for a different address, such as /test to see how the request changes. Well, the URI will change. Yep, we are attempting to get new. The only thing that'll change if you use a different browser is likely, well, if it's from mobile, it'll set that, but it'll tell you, hey, the user agent will be a bit different. You can also change the platform that you are utilizing, etc. This is just not a lot of this information will change from browser to browser, except for the user agent usually. As well as, of course, the accept encoding. If your browser does not support a specific type of encoding, if it changes the language, if it changes the well, that's about it, actually. Yeah, that's about it. Writing a response. We're going to implement sending data in response to a client request. Responses have the following format: HTTP version, status code, reason phrase, and character return line fill. Yep. Whatever that is. Headers, and then a message body. First line is a status line that contains the HTTP version used in the response, a numeric status code that summarizes the result of the request, and a reason phrase that provides a text description of the status code. Yep, so that's like 404 resource not found or whatever. After the CRLF sequence are any headers, another CRLF sequence, and the body of response, which is like your HTML. Here is an example response that uses HTTP version 1.1 and has a status code of 200. Okay. An OK reason phrase, no headers and no body. What would that do? I don't know. The status code 200 is the standard success response. The text is a tiny, successful HTTP response. Let's write this to the stream as a response to a successful request from the handle connections function. Right, yep. Let's keep that request in. I'm really curious to see what's going on with that. Right, so we're letting a response equal this string literal 200. Okay. /r/n/r/n. Two different ones to show that there is this is to say, hey, we're now on to headers, and then separately, hey, we are on to body. Body does not exist. So we're just going to, yep. We're just going to continue. Right, then we have stream.writeAll. Response as bytes. As bytes? Okay, yeah. But unwrap. No method named unwrap? Oh. Oh. Fool. Yep. WriteAll returns an option which we are unwrapping, which we still have no information for. Sure. Alright. That's working. Let's try this. Oops. Yeah. It'll just have an empty page. If we inspect, we'll see that there's nothing in here. Oh, oops. With the exception of, well, HTML head body HTML, which is just inserted by the browser to have this default space. Nothing is really changed here. I forgot what happens if we delete all the elements. Nothing. Nothing happens. Sorry. Very tired. I'm just... Right. So it worked. It worked fine. We got a request and a response within the body. And if I just put the letter A. So I'm guessing that we can just put any text in here. What if we just put in the letter A? Won't this just... Yeah, that'll just give us the letter A. Yeah. Where is A being placed? Pre. In a pre-block? Okay, it's within the body, but it's called a pre-block. Why is body not holding... Why is that black? We did! Why is it black? Its body is not... Okay, body is, in fact, not there. Since we put in A, we have... I've never seen that. Body should be the entire page's height and width and have a background of white, but since we have A here, it's decided not to do that. That is incredibly strange. I've never seen that. And where does free come from? Because our response body is just A. Huh. Okay, yeah, sure. Let's continue. The first new line defines the response variable that holds the success message's data. Then we call as_bytes on our response to convert the string data to bytes. The writeAll method on stream takes a reference to a U8 and sends those bytes directly down the connection. Because the writeAll operation could fail, we use an unwrap on any error messages as a result. As before. Again, in a real application, we would have error handling. With these changes, let's run our code and make a request. Alright, you should get a blank page instead of an error. You've hand-coded an HTTP request and sending a response. Woo! Returning real HTML. Let's implement the functionality for returning more than just a blank page. Create the new... Oh, okay, yeah, we're just creating a file. I thought for the entire time we would just be creating strings. Right. In the root of my project directory, we are creating hello.html. Good stuff. Inside of this, we are going to have, well, the regular prepend. I can never remember, what is it? Wait, do I not have a HTML LSP? Yeah, I do. Shame. That should work. Oh. Nope. Okay. That'll work, though. Been a while since I've actually worked with the right HTML. I'll admit. But hey. This is a minimal HTML5 document with a heading and some text. To return this from the server when a request is received, we'll modify the handle connection as shown in listing 25. Read the HTML file, add it to the response body, and send it. Alright. What is that? I don't know what is there. Alright, so we are going to add... What are we even adding? Buff reader. Yep, so, okay, we are going to first add in fs as an include. Good stuff. We are going to have the contents. Right, so this is going to be status line now. You're going to delete anything else. We'll add that in later. Oh, yeah, yeah. I should have done that in a different way. Now we'll change that later. Yeah, response will be built up later. So, yep, that's still correct. Let the contents equal fs.read, read to string, hello.html. And of course, we are going to unwrap that because this could fail. It outputs an option, and we don't care. Let the length equal contents.length. Huh. Okay, why? What are we doing with length? Okay. Let response equal format, which is a macro, of course. Status line. Right, yeah. So we got r/n. We're just going to build out the same response we had previously had, but with 3 different variables. Content length. Oh, the header. Right, so we're just manually adding in a header here, which is the length. Do we have content length here? No, because that's a get. I'm sorry, I forgot about that. That's a get response. This is all done for you in any actual server, of course. Alright. /r/n. So there's 2 character return. What was that? Did I miss something? We missed something. Headers. Right, so there's one originally for the HTTP thing. Then there's the headers, and then the message body. Why are we putting in 2 character return new lines? Here, though. Who cares? Oh, yeah, because the headers end when there are 2 character return new lines. Every single header is separated by a character return new line. Yeah, I understand now. Alright. I believe that's it. This should work now, right? I see no issue with it. I'm not going to read any more and am just going to do it. Hello! Hi from Rust. Okay, so the reason for the pre was because A was a header that didn't do anything, and that's, I guess, how headers that are improperly formatted are handled. They just get done like that. I don't know. But here we go. Hello, hi from Rust. We have a single threaded server. That's incredibly easy. I'm kind of disappointed. I thought it would be a heck of a lot more complicated. Right. We added fs to the use statement to bring in the standard libraries file system module into scope. The code for reading the contents of a file to a string should look familiar. We did in chapter 12 in our IO project. Next, we use the format macro to add the file's content to the body of the success response. To ensure a valid HTTP response, we added the content length header, which is set to the size of our response body. In this case, the size of hello. What happens if we don't do that? Sorry about this. I am just going to see what happens if we don't do that. I am very curious. Well, yeah, that's gonna... Apologies for honestly glad it isn't complicated. I understand. nothing happens. Nothing's wrong. Yeah, there's no issue if we just don't add in the length. Shame. Alright. I was kind of hoping for a bit more, though. This is incredibly simple, and most of it is hidden behind stuff that's already there. But you can make something much more complicated from this, and I likely will after we're done with the entire thing. Right, currently we're ignoring requests in the HTTP request data, and just sending back this unconditionally. That means if you try requesting anything else in your browser, it'll still get back the same HTML response. At the moment, our server is very limited and does not do what most web servers do. You want to customize a response depending on the request and only send back the HTML file for a well-formatted request to /. Okay? Validating the request and selectively responding. Oh, I guess we are getting a little bit more complicated. Ooh. Right now, the web server will return the HTML in the file no matter what the client requested. Activity public TCP? Heck yeah. I don't know how that would work, but that. Uh, right. Let's add the functionality to check whether it's requesting / before returning the HTML file and return an error if it requests anything else. For this, we need to modify ham connection as shown in listing 26. This new code checks for the content of the request received against what we know a request for / looks like and adds if and else blocks to treat requests differently. Good stuff. Right, what are we even doing differently? Not there, not there, not where? Oh, yeah. So we're just going to put all of this into what do we do? Oh, come on. What am I doing? I can't remember. Right, so we're just going to put all this into I'm an idiot. If request line which we are building up here. Buff reader. Oh my lord, what am I doing? Alright, so we got buff reader, and then we are getting request line. Sometimes I feel incredibly smart, and then I do anything, and, well, that notion is quite quickly gone out of my head. What? Unwrap, unwrap. What are we doing? Right, so that's just this, without the map, take, or collect. Which is just gone? We're no longer doing any of that. Okay, sure. Sure. Yeah, I don't know what I did that for. Dot next. Dot unwrap. That was terribly done. Okay. Yep. We're unwrapping twice. Create the request line. Sure. Then if the request line is equal exactly to get / HTTP / 1.1 Oh, okay. Yep. Ah, what in the world am I doing? Let status equal, yep, okay. Let contents equal that, that's good. Let length equal length, yep, response is the same. And writing it out, but else we are doing nothing. That must have been incredibly frustrating to watch, and I probably got something wrong. I understand what's going on. Right, so we have the entire I understand what's going on. So previously we were collecting the entire response and then pushing it all together. Currently we only want the first line. We're saying, hey, get all the lines, get the next line, which will be in this case the first line, and then just get that. Don't look for anything else. We're just getting the first line and nothing else, ignoring all errors. Good stuff. Well, not ignoring any errors, allowing any errors to bubble up as panic. Apologies again, I am tired, and yeah, that was frustrating. Semicolon? Oh no. Oh no, what have I done? Look, I have been writing a lot of go. That is my excuse. Secondary excuse, I'm an idiot. Thank you for that, though. Ah, we're only going to be looking at the first line of the H. It just says that right there, okay. So rather than reading the entire request into a vector, we're calling next to get the first item from the iterator, then the first unwrap takes care of the option and stops the program if the iterator has no items. Second, unwrap handles the result and has the same effect as the unwrap that was in map, adding listing 22. Next, we check the request line to see if it equals the request line in get. Let's just ensure that this is exactly what we're looking for. I know it's probably that, but I'm just going to do it anyway. Copy paste, just to stop any potential issues. Right, next we check, yep, if it's exactly request on the slash path. If it does, the if block, yep. If the request line does not equal the get request from the slash path, that means we have received best viewers on. Oh, wow. Not published to chat. Warn, timeout, ban. Goodbye. Run this code and, yep. We'll add code in the else block later. Run this code now and request 127.001.7878. You should get the HTTP in this. Yeah, we should just run this and it'll work fine. Not an issue. If it compiles correctly, if I typed in the words correctly. Nope. We fail. What? Okay. I messed something up. What is this? Right. Let's do some debugging. Nope, that's not what I wanted to do. Right, let's try. We can't just print out request line, can we? God, what is it? I can't remember. How do we print? This is my bane. How do we just print request line? That's not within the brackets. I don't know if that'll work. Is that correct? Who knows? Get slash HTTP 11. Right. Let's see if it gets into here. Are we actually sending any response? Yes. And we should have printed out something else if we failed. Connection established. We're not getting in here. We're not getting in here. Why? What? What? Oh! But I copied it directly from there! Where'd that come from? Okay. I thought I had copied it directly from here so that we wouldn't have that issue. I guess I failed to do so. Thank you for that. Capital letters are the bane of my existence. At one point, I failed an interview because of a capital letter. That is serious. An entire web server broke because I forgot to put in a capital letter in a place. People say semicolons are the worst. No, it's capital letters. You can't get proper errors than that. Right. That works. Oh, that makes me sad. Right, okay. We're only going to be looking at, yep. Next, we check, yep. If a request line does not, yep. Run this code. You should see the HTML response in hello.html. If you make any other requests to somewhere else, you'll get a connection error like you saw originally. Yeah, I thought it was just going to be one quick change. I did it on my phone, and then I went into the interview not knowing what was going to happen. It was terrible. I still... Hey, it was just for a co-op placement, and I got a decent co-op placement anyway, so you know, it was okay in the end. Now this code runs. Yeah, let's try something else, see what happens. Oh, I am curious. How many connection established get connection established? Oh, okay, sure, whatever. Slash this. We get nothing. And it tries multiple times. Good stuff. Let's add the code in the listing. Yep, let's add this to the response to give a 404, which signals that it was not found. Yep. We'll also return some HTML to render to say, hey, things got kind of fucky. Right. In the else statement, we have let status underscore line equals. I know better now. I'm going to ensure this is correct. And I don't have to learn that, you know, because everything else will do this correctly. All right. Let contents equal fs need to string. Why is this not auto-completing? I think I messed up somewhere. Dot unwrap. Why is this not? Because fn is imported, maybe? Oh no. Legitimately, I hate Go. I hate Go so much, it hurts me. Every other language just uses semicolons. Or doesn't care if you put them in. Go, though, will yell at you if you put them in. Alright. Length is the same. And then we have let response. It's response, not I keep putting C in there. My lord. Fine. And the format is probably going to be the same. Let's just see. Yeah, looks the same. Yep. And then stream.writeAll will be the same too. Should be good. Yep, she runs. All right, so we got to create. 404.html. And inside here, we are going to have h1 error. I really don't care what it's going to tell us to put in. I'm just going to write my own thing. Oops. 404. Oh, you fucked up. My understanding, this should work. Will this work even though... Well, yeah, that's not there, so... Huh. Yeah. Okay, so this web server does respond. You can just change this at any point in time. That's fine. Oh, perfectly fair. Nobody is, not even people who work as web devs. The internet is a horrific place made by megalomaniacs who hate life. Yeah, there's nothing special about 404 requests. They're just... All they are is just saying, hey, 404 not found. Technically, we could say it's something entirely different here, but then that would break an internet standard. There's a bunch of different errors, including one for I am not a teapot. That one's fun. Like this 404 not found, 502. I can't remember what 502 is. 502 is like a server responses. I think it's 406 or 407. That's I am not a teapot. So if you try and hit a coffee machine, asking it to be... I can't really remember. You can look it up yourself. It's kind of funny. I like that thing. Sorry, I am incredibly tired and not talking very well right now. Right. Here, our response has a status line with the status code 404 and the reason phrase not found. The body of the response will be an HTML file with 404.html. You'll need to create a 404 file next with the Yep, feel free to use any HTML you want, or use the example HTML listing 2008. Yep. So interesting stuff we just learned here, because I didn't have 404.html there at any point in time. This isn't reading anything into a binary. FS read to string is legitimately just reading at runtime. I don't know why I said that. I mean, it's fairly obvious, but I wonder if there's something that'll compile from a file at compile time. Not really relevant, though. And yep, we have this as the body here. I'm kind of curious what'll happen if we just don't put the contents in. No content. If it's just 404. Let's see. Failed to load resources. The server responded with the status of 404. Okay, yeah. That's simple. It'll just tell you in console, but it won't tell you on the page. It'll say page can't be found. Oh, yeah, it'll tell you right here. HTTP error 404. Yeah. Which is different than the normal response of not found. Okay. With these changes, run your server again. We already have. Congrats. Okay. A touch of refactoring. At the moment, the if-else blocks have a lot of repetition. Yep. Most of this stuff can be... What would I want? I'll just let them tell me, honestly. We don't have the mind for this right now. They're both reading files and writing the contents of the files to the stream. The only differences are the status line and the file name. Let's make the code more concise by putting those differences into separate if and else lines that will assign the oh, okay, yeah. I understand what it's going to get us to do now. Right. Let's just do this. Let status line equal this. Contents equal this. Is that what it's going to ask us to do? You know what? I'll just see what it does. Let's just comment all that out. Letting... Okay, so we're going to have a tuple for this? Every time I see someone use something like this with a tuple, it feels forced as hell. I see no uses for a tuple to set two variables. If request line is equal to exactly... Yeah. Nope. Not going to write that myself. Is equal to exactly that. This is an if let. Yep. And we're just going to take the inner here. Oops. Let's just take this entire bit. ASCII here. Along with file name equaling 404.html. Then we have an else, which is going to be the same thing, but with a 404. 404, not found. That should probably be all capitals. It's not okay. They try and tell you it's okay, but it's not. That'll be 404. This is not 404, this is hello. Okay. Is that good? We have an error somewhere. Yeah, we got that. Quest line. What? What's the issue now? That's fine. Right? Don't need that. Do we? Nope. Do want this. We're going to put in file name. I'm not going to be looking at any of that. I'm just going to try and see if I can get it without doing so. I understand this is fairly stupid. You probably shouldn't be doing that, but hey, it's good for learning. Probably. Maybe. Who knows? Status line is set up here. Contents is set here. And we write the response. I think that'll work, right? Right? Right. No errors. Let's see if that works fine. First try. Yeah, works fine. Good stuff. Now we have changed something which took much larger than that, and to something which takes much less than that. Very glad to see. This can now all fit in this very small box, and is quite readable. Good stuff. Alright. Now the if and else blocks only return the appropriate values for. Let's check to see if I did the exact same thing. Yep. Simply add the file name in here, and that's about it. Everything else kind of works together now. Alright, appropriate values for the line of file name into tuple. Then we use the destructuring to assign to these two values to status line and file name using the pattern in the let statement as discussed in chapter 18. Right, the previously duplicated code is now outside the if and else blocks and uses the status line and file name variables. This makes it easier to see the difference between the two cases, and it means we have only one place to update the code if we want to change how the file reading and response writing work. The behavior of this code in listing 29 will be the same as that in listing 27. Awesome. We now have a simple web server and approximately 40 lines of Rust code that responds to one request with a page of contents and responds to all other requests with a 404 response. Kinda. The 40 lines is only due to the fact that we have buff reader and a few other little things like TCP stream and TCP listener. That does the real heavy lifting here. We're really just utilizing these two crates or whatever, anything from standard. I can't remember exactly what it is. Is that a crate? Is that not? I don't remember. Hey, whatever. Currently, our server runs on a single thread, meaning it can only serve one request at a time. Let's examine how this can be a problem by simulating some slow requests. Yep. Right, so there are some things that we could do to add to this. Like, normally you could just put in like whatever around here and it will look for any file under that name. We could create a different folder called pages. Oops. Pages. And inside pages, we could have all of these HTML bits. And then from that, what we could do is we could simply append anything at the end of this, like a hello. Anything at the end of this, we could append here for the blank.html to get it from the pages folder. That way, without compiling the server or doing anything special to add this stuff in, we could simply add as many pages in as we want to have pages in our server. At which point we could just create as many web pages as we want without having to change anything in here. That would be better than specifically finding every single page which could work and updating the compiled code of our server to respond to any specific page which could exist. But hey, that's something additional, which if you want to continue work on this, you can. It would be more impressive to do so. But again, I am really liking this. This will be the end of today because it's 9:10. We don't have enough time to do the entirety of multi-threading, which is a very interesting thing. We'll do this in a week, hopefully. Well, I'm sad to say that you won't be there. Perhaps you'll be here for the last one, however, in 2 weeks, because this is essentially the end. This is the end of it, really. Thank you for joining us here. I'm excited to see what comes out of this. This is such a cool idea for a final project. Seriously. It's much better than like an adventure game. I've said this previously, I don't know if you hear from that, but like normally it's to-do app, it's like a notes application, it's like some random little thing, but this is something that you can kind of be proud of. This is an interesting thing to have done. I really like that they're adding this at the end. I'm not a great teacher, but I've been thinking of an idea of doing something similar for Python, where in order to learn it from a basic understanding, you're building your own little language within Python. Not all the lexing and all that stuff, you know. But I really like doing something that seems quite complicated, but in the end is fairly simple, as a request like that, as a an end to learning a language. I love that. This is impressive. It's interesting. It's not something simple. I like it. And in the end, you could use this. You could do stuff with this. I can't really think of what now, but this is cool. This is good, and I like it. Don't host this yourself, no. But that's gonna be it. Thank you again, Sorbet, for joining me. But I'm gonna head out. Catch you in 2 weeks for what will be the final stream of the book. It's been a good run. Hopefully we can move on to Activity Pub and Lemmy. Absolutely. Starting to figure out how Lemmy works. It still is going to be a shame to get to the end of this. Good night. Farewell.